I'm so happy to have you here, Unatti. Like, literally, I'm happy to have you in our office. For anyone watching, you don't get to see Unatti very much because Unatti runs our whole region for us in Asia. And so, but she's here in the U.S. for a few weeks, learning some of our new technologies that she can help bring back to our team in Asia. But we wanted to have you just come into the proof point here because there's a topic that is very it's becoming more prevalent in the market right now around thermal runaway and device failure because of thermal runaway. And we're not talking about like device failure where the device doesn't charge and it stops. I think that's a failure, but that's not catastrophic. We're talking about catastrophic failures like where phones are being melted, like the adhesive, where batteries are getting expanded to a dangerous point where literally plastic housings that house transmitters are inside. So we've talked a little about this in other segments, but since you're a technology expert, I wanted to ask your opinion of like, what do we do at NuCurrent? Because we do high quality designs and high quality technology. What do we do to prevent these catastrophic situations from happening?
Right. Thanks for having me. It's great to be back and meet the team here, and I'm excited to be back in Chicago.
Yeah,
It's
great to have you.
beautiful. I know it's winter, but still, it's amazing to be back in the city. I think you bring up a really good point. There are two important things that you need to take into consideration while designing for thermal runaway or safety. One is your system should have a foreign object detection.
Okay.
And then second, there are ways that you can use your software to avoid any thermal runaways and add extra safety.
Okay. So let's start with foreign object detect. What is foreign object detect and like how is it implemented?
Right. So foreign object, just the word says, right, foreign object which is foreign, which is not a part of your system
Sure.
design. So consider you're charging your phone and a card drops in between or a metal coin gets in between.
Like a credit card that has NFC tap to pair, so it might have some electronics in it, a coin, keys.
Absolutely. So those are not part of the system. They
Right.
are foreign object,
Yep.
and they can the NFC, not the NFC field, but the wireless power field
Yep.
can affect them in a way that the current that goes between transmitter and receiver can go through those metal objects
Right.
and start heating up.
Right.
Those objects can heat up, and then they can start melting the plastic around the
Yep.
phone or
Yep.
the receiver or what we call the charger.
Yeah.
And that's a safety concern.
The way I think about it sometimes is, induction cooking
Right.
is literally the purposeful induction of eddy currents in a piece of metal. When you put
Exactly.
it on top of something that looks a lot like a wireless charger, this is the accidental heating of an
Exactly.
object. So it's like, to me, it's like if you can boil water through this method of magnetic power transfer,
Yeah.
you want to be a little bit careful that you can also heat something to dangerous heating levels.
Exactly. And these are your day-to-day objects, right?
Yep.
It's so easy to put a coin on the charger or a key on a charger,
Totally.
and it's a safety concern. So your system design need to take into account that any metal funnel between, which is not a part of your actual charging system,
Yep.
and you need to turn it off. So there's a different foreign object detection ways that we do based on different technologies.
You mean like wireless power consortium, Qi versus
Exactly.
NFC versus like air fuel versus proprietary? Is that what you mean by technology?
Absolutely.
Okay.
So there are different ways to do it, but if I have to talk very high level, one of the important way is just calculate your power loss. Your charger or your transmitter should know what is the power loss in my system.
Sure.
And if the power loss is going above certain limit,
Yep.
turn off.
Yeah.
There's a safety concern. So you have to train your chargers in a way that it can understand the power losses are going above certain limit
Great.
and have that safety. So it's important, and we at NuCurrent absolutely take that into consideration
Sure.
for each and every design,
Yeah.
and it's very important.
Yeah, and it's a little different at different frequencies. It's a little different at different loads. So if you have multiple loads versus if you have a singular load, 1-to-1 versus 1-to-multiple, different distances. There's all sorts of different variables, but I think generally, as you said, that's the right way, which also leads really well into your second point, which is software controls. So why don't you talk about how software controls lead into those power loss calculations or other ways that we deal with preventing thermal runaway?
Right. One of the best ways your microcontroller or your system is sensing all the temperatures around it, right? The receiver and transmitter.
Yep.
And whenever our system sees, hey, the temperature is going above certain limit, even without reaching that absolute high limit,
Yep.
we try to control our power received.
Sure.
Using software control. So what happens, it's not an on and switch for the consumer. Like consumer won't see any difference between, hey, my phone is still charging. They won't
Still
see
charging, although realistically it's going to charge a little
just
slower.
lower
We'll put
rate.
in less current.
Exactly.
But it's, like you said, it's not an on-off. It's more like a dimmer.
Dimmer switch.
Yeah, okay.
And that dimmer switch is activated for only certain time.
Right.
Say the temperature cools down, you
Yep.
go back up again. So that is very sophisticated way to do it
Sure.
without affecting the end user performance.
Right.
They're still getting their devices charged,
Right.
but adds extra safety.
Right.
So rather than waiting for that absolute thermal shutdown, like,
Yep.
hey, I'm going way too hot, just turn everything off.
Right.
We take a step back, charge it slowly until the devices cool down, because maybe your it depends. Now if I have to talk in like American region, if you're charging in Arizona, it's
Yep.
going to be a different performance than Chicago in winter,
Sure.
right? It would be a different in Bangalore.
The ambient temperatures are
Exactly.
different, so that affects like the starting point of
Exactly.
thermal. Yep.
So where you are, it's going to affect your starting point, and that's going to affect your temperature rise as well. And
Okay.
hence, to have this switch is very important to get the best performance for the end user.
Well, that's awesome. So I'm gonna have to have you come to the U.S. more so we can do more of these together. But we'll take this one for now. Thank you so much.
Would love to. Thank you, Jacob.